What do you need to learn before you start learning data science? This is the answer to where do I begin when it comes to breaking into the data science and machine learning field from a learning path perspective. There are prerequisites for boot camps and any program, but we don't spend enough time talking about the real basics and fundamentals, what order to learn them in, and how to make your learning journey a whole lot more successful. Because without these prerequisites, most of the courses that you could sign up for, just you're not going to get a whole lot out of them because you're going to have to learn all these foundations just to really get your head around some of the concepts that they're going to be blazing through way too fast for you to really pick anything up out of. So let's start with math. This is the biggest, I don't know, biggest hesitation for most people is trying to figure out what math you need to learn before you learn data science. So you need geometry, just basic analytical geometry. Helps you understand machine learning a whole lot more. Continuing geometry, there's also differential geometry and topology. I think both of those are great to have, but you can definitely get into data science and machine learning without them. Those two will help you understand deep learning because there's a whole lot of concepts that are easier to visualize once you have a more advanced understanding of geometry. Graph theory is another excellent thing to know, but it's fairly advanced. Not every data scientist understands it. Calculus, all the way through. Go through multivariate calculus, learn the basics and some of the more advanced concepts. You will use these for years and you will spend years learning all of the practical applications for calculus, but learning the calculus just by itself only takes a few months. It's actually not that complicated. Linear algebra, you also need to know that, and it's very similar to calculus. Simple, very simple to pick up, so don't be intimidated by it. Understand that the implementations are the complicated part, and you'll be learning those for years. So don't feel like you have to be a master of any of these. Also feel free to come back to some of these concepts. Get a surface dive into the foundations of any one of these types of math, and then you're going to be able to come back and revisit with maybe some more applied knowledge later on. So you don't have to be an expert. You just want the foundations. When it comes to programming languages, my advice is have at least one programming language learned, just the programming language by itself, before you start any sort of data science and machine learning boot camp. Python is excellent, but if you already know C, C++, Java, C Sharp, Scala, there's tons of different languages out there that you could learn that'll give you just a foundational understanding of coding. Beyond coding, you need to understand software engineering. That's the study of how to create applications that are reliable, that are going to work, something that you could deploy, whether that's open source or it's something that you're deploying for business. Software engineering and systems engineering, both of those are key to basically be able to build things that work, be able to build high quality and, like I said, reliable. So excellent foundational knowledge in both of those core areas. Definitely think about doing at least software engineering patterns, practices, get that knowledge in you along with coding so that you can build for production, which is huge. Most machine learning jobs now require that. And you're going to get asked a whole lot of software engineering patterns and practices questions to make sure that you can build something that the business can sell. That's something that not every data scientist has, but I firmly believe every data scientist needs. Now, when it comes to tools, frameworks, architectures, you don't necessarily have to learn all of this up front. If you wanted to, I would talk about databases, something like MySQL, Mongo. Those are great to know. Definitely know SQL programming. That's okay. So some people may take issue to me calling that programming, but it's programming. Hopefully nobody gets angry in the comments at that. Learn because it's essential, especially for data wrangling and transformation. You have to have strong SQL skills, and it'll help you move through boot camps a whole lot faster. Although there are some boot camps that incorporate teaching you SQL into the curriculum, really hard to pick that up in 3 to 6 months and learn all the other stuff. So I'd say learn it on its own. When it comes to toolkits, if you're familiar with Python, Learning things like PyTorch, TensorFlow, getting to know some of the things like NumPy, SciPy, scikit-learn, all those are awesome, but you don't really need to go into a program knowing those. Most programs do a pretty good job of teaching you how to use each one of those packages. And if you already have some Python experience under your belt, you don't really need to know all of those toolkits and frameworks. When it comes to architecture, if you're going towards an ML engineering or very applied R&D role in data science, it's worth knowing core components of architecture. You can get to know things like Spark, get to know the Amazon stack, at least when it comes to spinning up instances and working with remote distributed resources. Good to get to know those. Things like SageMaker are good to explore a little bit. You can also do Google Cloud Platform. Azure is out there too. So if you've got familiarity with one or more of those platforms, those skills can transfer. Otherwise, it's worth getting familiar with. Should you do it before a program? Not necessarily. You don't have to know that going into a program. But if you're going more towards an architectural role or an ML engineering role, might be worth learning potentially in parallel or going a little bit deeper than you're going to get in a boot camp. Should you know an entire stack, like an entire architectural stack? That's overkill. And there's no consistency. I couldn't recommend, the reference stack because every company's different. Some companies are even building absolutely customized stacks, individual components all the way out to the whole thing. So there's no, hey, this is the stack. Learn about development environments, IDEs. Learn about Jupyter Notebooks. Those are awesome for data science, especially for a beginner. Really easy, really straightforward. If you learn about something like PyCharm, you can learn about Eclipse. You can learn about a number of easily accessible development environments. This is where you're going to write your code. This is where you're going to do a lot of your debugging, your unit testing. You can even push and deploy straight out of some IDEs for a very, very simple project. And as things get more complicated, you'll want to use more complicated features, more advanced features like profilers. And there's a ton of work you can do inside of an IDE that'll save you a lot of time. You also get a little bit of exposure to source control and things like Git, worth getting to know in advance. But again, you don't have to know all of this before you get into a program. It'll just make it easier to get through the program and focus on the machine learning pieces. So that's it. What else could you need to know? Science, the experimental method, experimental design, experimental execution, that's great to know. But that's a really advanced data science skill. We have science in our title, but typically the first year or 2 years that you work in the field, that's when you're going to start to understand the fundamentals of experimental design with respect to data science and machine learning. So it's awesome if you can learn that up front, if you can get familiar with it as part of the program that you're working in. That's an amazing area to look down because your career is going to depend on it. But do you need it in order to start a boot camp or start a program? Not necessarily, unless you want to dive deep into the applied or more academic research side of this. It's not a prerequisite. It's a really nice to have, and it'll give you some unique perspective on what you're being taught, because typically in a boot camp, you're taught very applied and with a deep focus on the model development side of your workflow. And sometimes the boot camp or the program that you're in can completely overlook the research side of our field. And so it's important. And sometimes this is going to be a bit of continuing education that you're going to have to pursue on your own. So that's it. Those are the prerequisites. And I've hopefully answered some questions that you may have about things you've heard that you have to know that not exactly requirements, but definitely good to know.